For this lesson, we'll back up a bit and cover the event we skipped during the other event tutorials. As we discussed in the physics bubble tutorial, objects outside of a certain range simply cannot have physics properties. You can of course extend the physics range, but this can quickly lead to performance issues. However, if you want to make objects move that are outside of the physics bubble, there is a way, and it's called the object position event. When you fire up the properties, you'll see a lot of options we haven't seen before, so let's check them out. The Modify Position checkbox decides if the event will modify the object's position. Local determines what coordinates the event will use to move the object. With this checked, the object's current position is 0 on all axes. When it's unchecked, the event will use the world coordinates. Next we have values for positions on the X, Y, and Z axes. When the event is activated, the targeted object will move to whatever position these values dictate, and this is where your data sources and operations come into play. If you simply put a new value in here, the object will immediately jump to that new location. Sometimes this will be useful, but often you will want the object to smoothly move to the new spot over time, so you'll need to tie these values to data sources or operations. Manipulating objects in this way is very similar to keyframe animation, so for the rest of the tutorial I will refer to this as animation. Before we move on to the rest of the properties, I'll give a few basic examples of different ways you can animate objects. If you're animating the object locally, the easiest way is with the curved data source. I've placed an object here, and let's say I want it to rise up. For this I will tie the y-axis value to a curved data source, which I've previously set up to change from 0 to 10 over 3 seconds. I will then scroll down the select event targets and choose my object. Now we're almost there, but remember, this tool is an event, so it needs an impulse to activate. Also, if it only gets one impulse, it'll only change the position one time to the value in our data source at the time that impulse reaches the event. So what we need is an interval trigger that is sending an impulse to the object position event every tick for the duration of the move. I've already set up my interval trigger to send an impulse every tick and then disable after 180 ticks, or 3 seconds. And now I'll direct it to activate the object position tool. A simple test in the editor by hitting the back button will show the results. Our object will rise up 10 meters. Next, let's consider if we're moving an object globally. A good example of this is getting an object to follow the movements of another object. In my example, the rider. For this, we will need a few data sources as well as an operation. We'll start with 3 object info data sources. I've set each one to position X, Y, and Z and set the target object as the rider's head. Now at this point, I could tie the X, Y, and Z coordinates in the object position event to the corresponding data source, but this would put my object in the exact position of the rider's head, and something tells me he wouldn't like that much. So now I'm going to use a 2-input operator to add a couple meters to the y-axis so that the object will be a bit above the rider's head. Now I'll open up my object position event. First, I'll uncheck the local checkbox. The object info data sources are going to produce the global coordinates of their target object, so we need the object position event to work globally as well. Next, I'll tie the X and Z coordinates to the X and Z data sources, but the Y will use the 2-input operator as its value target. Now, all that's left is our trigger. Since in this example we want the object to continuously follow the rider, we need the trigger to continuously send impulses. So we will use the same impulse trigger as before, but this time we will uncheck the disable after n impulses option. One thing you will notice as I begin my test run is at the start the object will snap to the position above the rider's head. This is of course because its starting position doesn't match up with the starting coordinates of the event. I'll cover one more method of animating objects, then we'll get back to the event's remaining properties. This time, we're still going to be moving globally, but instead of having the object follow another object, it is just going to move from point A to point B. For this method, we need 2 objects in the world to pull location data from, one at the starting position and one at the end. So I'll spawn a dummy object, then copy it and move the second one to my end position. Now we'll need 3 object info data sources for each dummy object, one for each axis. To save time, I've already set these up and connected them to my dummy object. Now we also need 3 curved data sources, again, one for each axis. I'll grab my first curved data source and tie the starting value to the X data source of the first dummy object. and then the end value to the X data source of the second dummy object. And I will also set the duration to 3 seconds. I'll repeat this step with the other two curve data sources using the Y and Z object info data sources. Once this is done, I'll connect the X, Y, and Z position values in the object position event to the corresponding curve data source. Our object is already selected and the trigger already set up from the previous example. Now all that's left is a quick test to see how our object will move. There is one last thing to notice that would be useful when animating globally. In both of our global examples, there was a jump at the start of the animation because the X, Y, and Z values of the starting position didn't match up with the actual position of the event. If you want these values to be equal, you can highlight an axis in the Position Events Properties menu and hit the X button. The value will automatically change to the position of your targeted object. You can then take that number and use it as the starting value in your curve data source. Once you've repeated this for each axis, reattach the object position event values to the curve data sources. This eliminates the need for the first dummy object. I hope that gave you a solid idea on the many options you have for animating objects. There are of course other methods, but once you understand the basics of using this event, the possibilities of what you can do will start to expand. Now that was a lot of info, but we've still got a little more to cover. Fortunately, the next set of options work basically the same, but now for rotation instead of position. The Modify Rotation checkbox of course decides if the tool will try to change the rotation or not, and just as before, Local determines if it will use the values of the object as a base or global values. Yaw, Pitch, and Bank refer to the different types of rotation. These are technical terms that have to do with rotation, but the concepts are the same as the three axes we're used to working with. Since we're dealing now with rotation instead of position, our values here represent degrees of rotation instead of meters. So a change from 0 to 360 would be one full rotation. Besides that, the potential processes of animating rotation are the same as they were for position, so I'll not do any further examples here. All of the remaining options are ones that hopefully are fairly familiar to you by now, so that concludes our lesson on the object position event.